Hey everyone, I'm Anesha from IBM, and today we're going to be talking about an introduction to artificial intelligence. More specifically, I can help provide an introduction to the concepts needed to understand how artificial intelligence can be used for drones. So what exactly is artificial intelligence? The definition we'll give today is that artificial intelligence is the capability of a machine to imitate human intelligence. So it's a branch of computer science dealing with the simulation of intelligent behavior. What exactly does human intelligent behavior mean? How can we classify human intelligence? Well, AI systems will typically demonstrate at least some of the following behaviors associated with human intelligence: planning, learning, reasoning, problem solving, knowledge representation, perception, motion, and manipulation, and to a lesser extent, social intelligence or creativity. If we can imitate human intelligence, well, what can we do with it? Here are some examples of AI systems existing today, or that may exist in the future. Some things you may be familiar with include chatbots, self-driving cars, being able to predict the future, AI doctors, speech recognition, AI music composition, AI image recognition, and of course, drones that use image recognition to conduct tasks. Some more specific examples of AI that can be used with drones include using AI and drones to deliver packages, or using camera sensors on drones to recognize faces in a crowd. AI itself is a big term and encompasses a lot of things. So breaking down artificial intelligence, machine learning is a subset of AI that refers to AI systems being able to learn without being explicitly programmed. Another buzzword that comes up often is deep learning, and that's just a subfield of machine learning that uses neural networks to simulate human decision making. So going into a definition of machine learning, we can say that, evolving from the pattern of recognition and statistics, machine learning is the field of building models to classify and make predictions from data, instead of following rules-based algorithms. So what does that mean? Let's go into an example of a problem we may be able to tackle with machine learning. What if we wanted to determine whether a certain plot of land needed to be watered or not in a farm, which is a real issue that farms have to deal with and keep track of? Let's say we are given data such as whether the field was last watered, the current time, size of the field, what crop is on the field, the temperature, and the result, whether the field needed to be watered or not at that given time. With machine learning, given this data set, we are able to learn and create a model that, given inputs, will predict results. So what exactly is the difference between this and using statistical analysis to create an algorithm? Well, an algorithm is a mathematical technique. So with traditional programming and algorithms, we take data and rules and use these to develop an algorithm that will give us answers. So in the previous example, if we were using a traditional algorithm, we would take the data and use this data to create an algorithm that would determine whether the crop needed to be watered or not. This algorithm, for example, could be saying something like, if the temperature is higher than 70 degrees and 2 hours have passed, then you need to water the field. Essentially, it will be an if-then-else statement. When you submit inputs, we will get answers based on what the algorithm we determined is. The thing is, the algorithm will not be changing. Machine learning, on the other hand, we take data and answers to create the algorithm. Then at the end instead of getting answers, we already have the answers. We get a set of rules that determine what the machine learning model will be. So going back to the previous example, we would essentially look at this data, look at the results, and develop an algorithm, which is the model that determines what the rules are, that determines what the if-then-else statement would be when we get the inputs. Essentially, what this model does is determine what the parameters are in a traditional algorithm. Instead of arbitrarily deciding that if the temperature is higher than 70 degrees and 2 hours have passed, then you have to water the field, we use this model to determine what that logic will be. Essentially, machine learning helps find the parameters of our if-then-else statements. This model, unlike a traditional algorithm, can continuously be trained and be used in the future to predict values. With the previous example, as said before, with classification, we extract features from the data. The features in this example would be temperature or size, as these are the categories or classes. Features are distinctive properties of input patterns that help in differentiating between the categories of input patterns. Each column is a feature. Each row is a data point. What we did in this example of classifying whether land needed to be watered or not is called classification. Classification is the process of predicting the class of given data points. A classifier utilizes some training data to understand how given input variables relate to class. In this example, our classes were true or false, referring to whether the field needed to be watered or not. Machine learning is a broad field, and we can split it up into 3 different categories: supervised learning, unsupervised learning, and reinforcement learning. There are many different tasks that we can solve with these. Supervised learning refers to when we have class labels in the data set, and we use these to build the classification model. What this means is when we receive data, it has labels to say what the data represents. In the previous example, we had a table with labels such as time or type of crop. With unsupervised learning, we don't have class labels, and we must discover class labels from unstructured data. This could involve things such as deep learning, looking at pictures to train our models, things like that. This is typically done with something called clustering. Reinforcement learning is a different subset, and what this does is it uses a reward function to penalize bad actions or reward good actions. Breaking down supervised learning, we can split it up into 3 categories: regression, classification, and neural networks. Neural networks refer to structures that imitate the structure of the human brain. Regression models are built by looking at relationships between features x and the result y, where y is a continuous variable. Essentially, regression estimates continuous values. Classification, on the other hand, focuses on discrete values. It identifies unique classes. We can assign discrete class labels y based on many features x. The example we gave on the previous example was an example of classifications, where the classes would be the field needs to be watered or the field does not need to be watered. Some forms of classification include decision trees, support vector machines, logistic regression, and random forests. So let's talk about limitations. If we talk just about machine learning, it's not as useful with large amounts of inputs and outputs, aka high-dimensional data. Furthermore, it's not good for feature extractions, which refers to discovering what the features are from unstructured data, especially with image recognition. Image recognition, of course, is really important when it comes to drones. To tackle that, we have deep learning. Deep learning is a subfield of machine learning concerned with algorithms inspired by the structure of the brain called artificial neural networks. The design of an artificial neural network is inspired by the biological neural network of the human brain. Basic machine learning models do become progressively better at whatever their function is, but they still require some guidance. If a machine learning algorithm returns an inaccurate prediction, then an engineer needs to step in and make adjustments. But with deep learning model, the algorithms can determine on their own if a prediction is accurate or not. Let's go back to the example of whether a field needs to be watered or not. With machine learning, perhaps the model would recognize, for example, that crops will need to be watered given some ratio between time and temperature. Eventually, given more training, the model might be able to correctly classify whether a field needs to be watered or not given those parameters. Deep learning could potentially look at unstructured data such as images or videos. The downside is that deep learning needs more processing and computing power than machine learning. However, after looking at images of a field, it would be able to determine what features are important in order to classify the field as needing irrigation. Essentially, deep learning can automatically discover the features needed to be used for classification, rather than having them manually provided like machine learning requires. You wouldn't need a table of information about the field. You could perhaps instead use a drone to survey the field instead. The deep learning model is able to learn through its own method of computing and its own brain. Since pictures don't have class labels, it is unsupervised learning. We can break down unsupervised learning into subsets: clustering, anomaly detection, and neural networks. Clustering allows us to infer labels on unlabeled data. We take a group of unlabeled data and cluster it to form categories. An example would be identifying different kinds of car accidents and dividing it into 3 groups based on clusters. Some important clustering algorithms are k-means clustering, hierarchical clustering, dbSCAN. Anomaly detection is used to find anomalies in data. A sample use case is a drone looking for abnormal behavior in a crowd that could signal terrorism. Some important anomaly detection algorithms are k-nearest neighbors, support vector machines, and k-means clustering. So what allows drones to use these machine learning algorithms? Some important concepts to note include machine perception. Many AI-related tasks for drones are dealing with image recognition. The drone must be able to perceive and absorb the environment or objects in some way. They do this using sensors such as electro-optical, stereo-optical, and LiDAR. Computer vision is another important term. Once the drone has captured raw sensor data, it usually needs to be analyzed in some way to extract meaningful information. This ability is called computer vision. This is concerned with the automatic extraction, analysis, and understanding of useful information from one or more images. Now that you understand how drones use AI, there are limitless industries where you can use them. Some industries include military, agriculture, systems designed to help crowd safety, surveillance, disaster aid, or commercial shipments. Do you have any ideas what you would want to use a drone for involving artificial intelligence? Now that you understand the basic concepts of what machine learning and AI are, you can use Watson Studio and IBM Cloud to get started doing it yourself.